Hello everyone. Today we will study another interesting topic of physics, that is pulley. Really interesting, and you will find that how do we apply the free body diagrams, free body equations to find the tension and the acceleration in the pulley. So first of all, the simplest case of pulley which we have in our course is the pulley which is attached to the support like this, and a string is passing over it having two masses m1 and m2. Now if m2 is greater than m1, obviously the system will come this way. So the motion of the system will be this way on the second mass and this way on the first mass. Now we have to mark all the forces acting on it. So what all are the forces? First thing, we know very well that this is the weight of this mass. So you can say that this is m2g. This is the weight of this mass. This is m1g, because weight is the force which always acts downwards, right? Now we have the same string which is passing over the pulley. So this same string is passing over the pulley. Now in the video for the tension, we have studied that the tension in the same string will be same at every point. So that's why if we are marking the tensions in this part of the string and in this part of the string, it will be same. And the way or the trick to mark tension is away from the body, because it pulls the body. With the same force, this body also pulls it from here. So similarly, here this tension pulls the body this way, this tension pulls the body this way, and by Newton's third law, the same tension will be applied here also. So the net tension over here is 0. Or you can say that if we want to draw the free body diagram, we need to mark the acceleration with which these bodies are moving. So for drawing the free body diagram, what are we supposed to do? So we are talking about the mass m1 and we will talk about the mass m2 also. What we are drawing now? We are drawing the free body diagrams. Okay. Now for the free body diagrams, I will mark all the forces acting on it, as we know that. So this is m1g and the upward force is tension. Here this is m2g and this upward force is tension. Now this system is moving with acceleration this way. This system is moving with acceleration this way. Now these are the free body diagrams. Now what are we supposed to do? With free body diagrams, we can write the free body equations. So now we are writing the free body equations. For the first figure, or you can say the A figure and B figure separately. So for A figure, what will we use? The Newton's second law, that is net force along motion is equal to mass into acceleration. Right? So what is the net force on this? See, this mass is moving up. So this force, tension force, will be greater than the weight of mass m1. So I can write T minus m1g is equal to m1a. Similarly for this mass, since it is moving this way, so m2g force is greater than the tension. So I can write m2g minus T is equal to m2a. Why here I have written m2? Because I am talking about the free body equation of m2 mass, right? So now if I add these two, what will I get? I will get T minus m1g plus m2g minus T is equal to m1a plus m2a. Yes. So this will give me m2 minus m1. I can take g common here. Why? Because these two terms were left. This is cancelled. Yeah. Now from here I can take a common and I will get this. No problem, as simple as that. Now acceleration will be m2 minus m1 upon m1 plus m2 g. Yes, so difference of masses multiplied by the acceleration due to gravity upon sum of the masses gives the acceleration. Now if I have to find the tension, then again I'll use the same equations. But what will I do now? I will divide the first equation by the second equation. Okay, so I'm rubbing the diagram now. So if I divide for tension, what am I doing? I'm dividing equation 1 by 2. Yes. So what will I do? T minus m1g is equal to m1a. m2g minus t is equal to m2a. Okay. So these are the two equations. Let's mark these. These are the two equations which we already know. We just have to divide that. So we have divided. Okay. This will be cancelled. Let's cross multiply now. So this will be m2 into t minus m1 m2g is equal to m1 m2g minus m1t. Let's shift it here. So this is m2t plus m1t is equal to m1 m2g, shift on right, plus m1 m2g. Let's solve it. Take t common. This is m1 plus m2 and this will be 2m1 m2g. Yeah. So the tension is given by 2m1 m2g upon m1 plus m2. So this is the formula for the tension. You can get direct questions based on the formula. If you are given two masses, suppose 3 kg and 2 kg, what will be the acceleration? You can easily find the acceleration using this concept. You can easily find the tension using this concept. Now we will take the second case of motion of connected bodies, and that is the blocks kept on a table. So this is the second case, that is the blocks connected by strings on a table, right? So if I have the three boxes like this, so if I have this mass m1, m2, m3 connected by string, this here and this here, this is m1, m2, m3. A force is applied towards right. So this is the applied force, right? Now we have to mark the tension. We know that there is a tension between these two strings and these these two masses on the string between it. The same string is there between these two. So I can mark that these two tensions are same. For this, I will mark this tension away. So if I'm marking this as tension 2, so this will also be tension 2. This tension is marked away from this mass. Now here also tension away from the mass, here also tension away from the mass. This is T1, this is T1, right? And the whole system is moving this way. The whole system is connected. So whatever acceleration this force is providing, the same acceleration is applicable on every mass. I hope this is clear. So that means now if I consider the free body equations of free body diagrams of these masses. So first what will we do? We will draw the free body diagrams. So what free body diagrams? We have to consider the first point for M1, second point for M2 and third point for M3. And we have to mark all the forces acting on these. So on this mass, the force acting is T1 and acceleration is A. On this, T2 is acting this way, T1 is acting this way, and the acceleration is this way. On the mass M3, the applied force is F, the tension is T2, and the acceleration is this way. Now what? Now we'll have to write the free body equations using Newton's second law. What is that? That is net force along motion is equal to mass into acceleration. Yes. So net force along motion for mass M1 is T1. Only T1 is the right force. So this is M1 into A for first mass. For second mass, net force along motion, obviously the motion is right side. So which one will be greater? T2 will be greater. So we will have T2 minus T1 is equal to M2 into A. Similarly for this, F minus T2 is equal to M3 into A. So these are our free body equations. Now one formula for acceleration which is very important for you to understand here is that acceleration is equal to applied force upon total mass moving. So this acceleration is equal to, what is the applied force? F. What is the total mass? M1 plus M2 plus M3. So this becomes a very important equation number 4. Now you have these 4 equations. You can easily find out whatever you want to find out. I can simplify this formula. See, T1 is already simplified from equation 2. I can simplify that so that you can apply it directly later on. So from 2, T2 is equal to M2A plus T1. Yeah, and we know that M2A, T1 is what? M1A. Yes, so here I will write from equation 1. Here I can write M1 plus M2 into A. Now I can replace this acceleration from equation 4. So this is M1 plus M2 upon M1 plus M2 plus M3 into F. This is from equation 4. Yes, interesting. Similarly, you can find this force also. So this force is equal to M3A plus T2. So this means M3A plus M1A plus M2A. It's already equal to force only. So this is, from here you could have calculated this. So F is equal to m1 plus m2 plus m3 into A. From here you can get the formula which we have directly written over here. So this is all about the connected motion of the blocks on a horizontal surface. I hope you understood this. That's all for now. Have a nice day.